Hi, my name is Liam Rushton and this is my demo video for my third year project, an investigation into malware intelligence. Now during this video I'll be showing you the setup created using ESXi, a VMware tool, and basically guiding through all of the processes that I've done there to set up a network with interlinked virtual machines, which can serve as the test bed for this experiment. So what we can see here now is the 10 VMs setup. We have the Ubuntu server and then 9 Windows 10 VMs, which are linked up through a internal network, which we'll show here. So as you can see, there's this network named internal, and basically all the VMs are connected to that. It just acts as a switch. If we now have a look at the server, we can see, all the hardware for it. We can see the current performance and the addresses assigned to it. If we look at the other ones, we can actually see that server is giving out DHCP addresses. So we'll see here that there is this 23.rage that all of the Windows 10 VMs are connected to. We have here a diagram of the DHCP setup on this project. So the Ubuntu server basically acts as a DHCP server and gives out addresses on the 192.168.23 subnet. All of the Windows 10 virtual machines and the TinyCore machines within them as well are configured to fetch an address through DHCP when they boot up. When they do this, they obviously get a response from the server, which offers them a Pixie boot up as well, and that's how they load various operating systems and the Clonezilla tool. Now this diagram shows the flowchart process for all of the scripts on the various operating systems. So as you can see, it's sorted into Ubuntu server, Windows 10 and TinyCore, and highlights at what points it swaps between them and how they interact basically. So we initially start off with the script being booted up on the Ubuntu system. It's loaded in with a malware sample thanks to EXP runner, which selects one from the long list that we have in there. After that, the script moves into the Pixie Linux directory, just to make sure that we're operating in the right area, and then it scans for any existing beacon or virus files in the folders within there that might be left over from the last run, and make sure that they're removed first so that they don't cause any complications during the running of this script. After that, we go to creating the new FTP virus file. So the file that is loaded in as a variable is then symbolically linked to a new file, which is the one that will be transported to Windows over FTP. The script then boots into Clonezilla. It does this by rebooting the currently open Windows 10 VM and by modifying the Pixie boot file so that the menu has the different default option. Part of the video later will show this, so I can illustrate what this means, but once it does that, it starts booting up into the Windows 10 VM after the restoration's done. So that's when we swap over to Windows 10. Upon booting up, it fetches its DHCP address from the Ubuntu server, so it's connected across the same network and is able to access it. So then, after Windows 10 is booted up, it launches a script from the desktop. This is set to run on startup. When the file launches, it FTPs across to the Ubuntu server, fetches the malware file and pulls it back onto the PC. It then renames that file from a text file to a bat file so it can now be executed, and then runs that file. This will then infect the target machine. During this, the Ubuntu script has changed over the Pixie boot menu configuration again, so that it will naturally boot into TinyCore on the next restart. It then issues the same restart command as it did earlier in the script to the Windows 10 machine, which is rebooted into TinyCore on the second partition on its drive. Upon Tinycore booting up, it fetches a DHCP address from the server, so it's also connected on the same network and is able to access it. The Windows partition is mounted as the second drive on there, and then each file on the Windows partition has a SHA-256 hash generated. Recursively, the script runs through every file and every folder on there, and it generates a SHA-256 some hash, and then puts it into a file called hashinfected.txt. Once this is done, the file is then compared to another file called initialhash.txt. Now this file was generated when the recovery images for Windows 10 were, so all of the files on there, except for volatile files like temporary files or anything like that, will be exactly the same. So any files that are modified by the virus when it's installed on Windows will generate different sums, and we'll be able to spot those in this step. The results from that are then put into a file, results.txt, and they're sent back to the Ubuntu server through FTP along with a beacon file to signify that it's finished this process and that the Ubuntu script can now finish its section. The Ubuntu server spots that the beacons come across, renames the result file to a unique name, and then removes any remaining beacon files and gets ready to exit to the next loop. So this is actual VMware workstation, which is plugged into the server, so you can run the VMs on a local machine. So if I go to var lib tftp boot, where is it? There it is. And then to, well, these are all of our Pixie setup files. This is the virus share sample, which basically was a sample of 160,000 pieces of malware from online that I gained access to as a research thing, basically. The beacon folder, which we'll explain a bit more later. Clonezilla, so this is where through the Pixie menu, any VMs can pick up a Clonezilla installation and start doing operations on there. And this is where these images are stored. So these are the backups of each of the Windows 10 machines, which are used in the experiment as like a clean base before the machines are infected. We have our malware samples, which I'm not going to open up because there's a lot in there. These are the results. So as you can see, there's already been 3 test runs, which has given out a few results. Yeah, these are the other ones. So these were basically just iterations of the loop before it was started permanently, or for the duration of the experiment. Yeah, as you can see, there's a selection of malware in there. The whole sample wasn't used due to a lot of the samples being like non-executables, a lot of HTML files and things like that. In here we have our Pixie boot menus. We have quite a few different types for each VM, basically due to the bootload, like the order on the menu. So certain ones will start up Clonezilla first, certain ones will boot into Tinycore first, some will boot into Windows first, and basically the script that manages each of these experiments swaps out those files as it needs to. So we'll be able to see those in here. So these are the log files from the previous runs, and there are scripts. That's erunner, which is the tool which is used to basically give this iterative experiment. It'll repeat the experiment given a number of variables, and these scripts. Now with these scripts we can see here, let me just try and open one up for a moment. In the scripts themselves, there is the variables that are used in the erunner program, and basically these include the script that's being run in this case, and then every sample of malware in that directory, as you can see there. So it kind of operates on a, if you give it A, B, C, and 1, 2, 3, that'll do A1, A2, A3, B1, B2, B3, etc. It'll just run through all the possible combinations. So we've used these scripts and plugged in the malware value at the top, and basically it it carries out the whole script using that piece of malware. Now looking at this script, obviously we can see at the top it takes the variable passed in, which is brought in from erunner, which is the malware value that's currently selected in that long list. So each one has a MAC address set. And if we look at the commands below that, we have initially it moves into the required Pixie Linux directory, and then from in there it starts creating a malware file which will be sent to the Windows machine. It does this via a symbolic link to the basically the variable passed in. So this FTP virus file, which is made per system using their MAC address, is then created ready to be FTP'd across to Windows. And then past that we have, so the CP command is basically what we were saying earlier about the Pixie menu different configurations. This is one that means that when it starts up, it'll start into Clonezilla and start refreshing from that preset image where it's a clean version of Windows 10. And then the command below it reboots it from Windows. So at the start of the experiment, all the machines are booted up into Windows. They'll get given that command, they'll restart and load into Clonezilla. And then whilst Clonezilla is running through, the Windows Pixie boot file is copied across, as you can see there near the bottom. And for the rest of the script, we have basically the check for the beacon file. So once the Windows machine starts running, it basically boots up into a script. This script carries across the malware file that we've created. And tries running that, and then once it's done that, it creates a beacon file which it pushes back onto the server here via FTP. Only once that beacon file has been found by the script on Ubuntu will it then issue the command to reboot back into TinyCore so that it can start examining the hard drive then. So we can see there it checks the beacon, it then removes it, ready for the next cycle, issues the command to reboot into TinyCore with again an update of that Pixie boot menu there, and then it waits whilst that loads up. TinyCore will start running its script at that point. We'll show all this in a little bit, and then it'll copy the Windows Pixie boot back onto there again. So that it's ready. At the end of that script, it reboots naturally after the hash has been compared. And when it does, it'll boot back into Windows, finish up the script by clearing up anything left over, renaming the results file to a unique name, and then exits for the next loop. So now if we swap over to the Windows 10 VM, we can have a look at the setup on there. So this is the script that runs on startup. It's just a bat file. As you can see, it starts up, generates a script to log in via FTP, so it issues those commands into a file and then runs that file later. And then basically once it's in FTP, it will grab the malware sample from the server and bring it back onto this machine. It then tries to rename the file, due to it having executable contents, puts it into another bat file and then tries to execute that to run the virus, and then creates a beacon file to FTP back onto the Ubuntu server to say that it's ready to move on to the next step. So let's close that, and these are the beacon files that are generated. You can see it there. If I now try to restart the VM, I can boot it into TinyCore, as TinyCore is on another partition on the same drive as the Windows 10 installation. So basically what would happen is by default it would run that script, try running the virus, and then it'll boot up into TinyCore here. You can see the Pixie boot menu here. So we got Windows, a restore, TinyCore, and then the Clonezilla general operations for making new images and things like that. So if I boot into TinyCore now, so there by default it was going to run the script on startup, but I just cancelled out of it, and that's the hash infected that it generates as part of that script. And the initial hash is the one that already exists on the drive, which is the hash of all the files on the Windows 10 image. So if we have a look at the actual script on here now, then we can see again it's got the MAC address of the device, and basically this script focuses on mounting the drive that Windows 10 is installed onto, and then using the find command it basically generates a SHA-256 sum for every file on the drive, and once it's generated that enormous list of hashes, it'll then use the diff command to compare it against the initial hash file generated, and anything that's been modified is then written out into that results file. So once that results file has been generated, you can see that the file is then FTP'd back over to the server along with the beacon, which will then signify the script to carry on in its process, and we've also got our results on the server then which can be examined. So now we're going to see a full demo run, one cycle, one piece of malware going through this whole system and the results that it produces. So we're going to launch our erunner command, and I'm going to speed through the next couple of steps. So this is the Clonezilla restoring a fresh copy of Windows 10. So this is again through that Pixie menu, it picks up an image, the image is a per machine, and it just automatically starts restoring that. So this is a clean image with no malware on it. This will now boot into Windows for us, and basically once this boots up it'll run that script that we saw earlier on. So once it gets the piece of malware across, it will try and run it as a bat script, which obviously due to the executable contents, it will be able to launch it as such. Once that's done, the machine then generates the beacon, pushes the beacon back over to the Ubuntu server. You can see the malware warning there at the bottom right, and then we can restart the machine and boot it into TinyCore. And I'll speed up this process again here. So this is where the TinyCore script is running. So this will be taking a SHA-256 sum hash of a SHA-256 hash of every file on the Windows drive, compiling them into a long list, and then comparing them to the initial hash file that we had on there to spot any files that have been modified on there. And with those modified files, we can then rule out things like temporary files that are different on each startup or things like that, and anything that's been modified in terms of system or program files. You know, we can figure out what this virus has been doing, what it's been modifying in there. And in here we now have a new file, as we can see, and if I check the properties on that, it should show it as having some contents. So basically that file will just be a list of files that have been modified on that Windows system compared to where it was restored from. And we can see the beacon file that Windows also put in here, which will be removed at the start of the next cycle by the script. Okay, so what we're looking at now are the 9 scripts open for each of the virtual machines, and this is running them all at the same time. So it's just to show that these 9 different scripts do different things, and I'll flick through them all now, and you can see they're all at various steps now of going through this cycle. Some are still waiting to reboot, and some are already into the Clonezilla processes. And that concludes this video for a project demonstration. I hope that you enjoyed it, and if you have any questions then please feel free to email me at lrushton1@uclan.ac.uk. Thank you very much.